Students of Standard 10, let's begin with the second part of acids, bases and salts. We have completed acids, we are going to start with bases. Now let us define what is a base. Now oxides and hydroxides of metals are called as hydroxides and oxides of metals which react with hydronium ions of an acid to form salt and water only is called as a base. Example, copper oxide is a base. Magnesium hydroxide is also a base. As I told you, metallic oxides and hydroxides are called as bases. They react with hydronium ions of an acid to form salt and water. Let's see what is an alkali. A soluble base is called as an alkali, or an alkali is a basic hydroxide which when dissolved in water forms hydroxyl ions as the only negatively charged ions. That means an alkali is a base soluble in water that turns red litmus blue. Now all metallic oxides and hydroxides are insoluble in water except sodium, potassium and calcium. So all alkalis are bases, but all bases are not alkalis. As I told you in the beginning, all alkalis are bases means all soluble metallic oxides and hydroxides are bases, but all bases are not alkalis because all metallic oxides and hydroxides are not soluble in water. Example of strong alkali is sodium hydroxide and potassium hydroxide. Example of weak alkali is calcium hydroxide and ammonium hydroxide. Now let us classify bases, that is alkalis, on the basis of the strength as strong alkali and weak alkali. That which undergoes complete ionization in aqueous solution to form high concentration of OH minus ions is called as a strong alkali like sodium and potassium hydroxide, and an alkali which undergoes partial dissociation or ionization in aqueous solution to produce low concentration of OH minus ions are called as a weak alkalis, ammonium hydroxide and calcium hydroxide. Now next, this bases on the basis of their acidity. Now the number of hydrogen ions with which a molecule of that base will react to produce salt and water is known as the acidity of a base. Now based on this monoacidic base, the base that dissociates in the fused state or in the aqueous solution to produce one OH minus ion per molecule of the base is called monoacidic base. Sodium hydroxide, potassium and ammonium hydroxides are monoacidic bases. In the same way, the base that dissociates in its fused or aqueous state to produce 2 OH minus ions per molecule of the base is diacidic base like calcium hydroxide and copper hydroxide. If it is a base which dissociates in the fused or molten or aqueous solution state to produce 3 OH minus ions per molecule of the base is called as triacidic base like aluminium and ferric hydroxide. Learn how to prepare these bases. We can prepare bases from metals, prepare bases with action of water on reactive metals, also action of water on soluble metallic oxides. Now how would you prepare bases from metals? When metals react with oxygen they give bases like sodium burns in air to form sodium oxide and magnesium in air to form magnesium oxide. When water is added to make metals, highly reactive metals like sodium, potassium, calcium, they form the respective hydroxides. Again, when water is added on soluble metallic oxides like sodium oxide, potassium oxide and calcium oxide, they form alkalis like sodium hydroxide, potassium and calcium hydroxide. These are all called as the bases which are prepared from metals. Next, double decomposition reaction. When aqueous solution of salts, they react with a base, PPT is formed. Now ferric chloride reacts with sodium hydroxide, ferric hydroxide and sodium chloride. Same way copper sulfate reacts with sodium hydroxide from copper hydroxide and sodium sulfate. And aluminium chloride reacts with ammonium hydroxide, aluminium hydroxide and ammonium chloride. This ferric hydroxide, copper hydroxide and aluminium hydroxide are all PPTs. Now next, by the action of metals on metal sulfides, metal sulfides, they react with oxygen like zinc sulfide, lead sulfide. They form the respective oxides like zinc oxide and lead oxide, along with the liberation of sulfur dioxide gas. Now decomposition of salts like calcium and copper carbonate, when heated, they decompose to form the respective oxides and carbon dioxide gas is liberated. Now the next, what are the properties of bases? Let's concentrate on the physical properties first. All bases have sharp and bitter taste. They turn litmus blue, red litmus blue, methyl orange yellow, phenolphthalein colorless to pink. Insoluble bases do not affect the indicators. Bases have a soapy substance which is slippery to touch. Next, the chemical properties. Now, chemical properties like strong alkalis like sodium hydroxide and ammonium hydroxide, sodium hydroxide, potassium hydroxide, they react with carbon dioxide gas to form their respective carbonates and water. They neutralize acids to form salt and water. Like calcium hydroxide, ferrous hydroxide react with acids to form the respective chlorides, HCl to form respective chlorides and water. They form a salt and PPT hydroxide when reacts with metallic salts. Like ammonium hydroxide, sodium hydroxide, they react with copper sulfate and zinc sulfate to form the respective sulfates. And insoluble hydroxides like copper hydroxide and zinc hydroxide is formed. Copper hydroxide is a PPT, pale blue PPT, and zinc hydroxide is a gelatinous white PPT. Now when bases react with ammonium salts also, ammonia gas is liberated. Like sodium hydroxide, calcium hydroxide, they react with chlorides of ammonia to form the respective chlorides and ammonia gas is liberated. Now, what are the uses of bases? Now each and every base has its particular use. Sodium hydroxide used in the manufacture of soap. Potassium hydroxide is used in alkaline batteries. Calcium hydroxide as slaked lime, bleaching powder and softening of hard water. Magnesium hydroxide used as an antacid. Aluminum hydroxide as foaming agent in fire extinguishers. Ammonium hydroxide to remove grease stains from clothes. And magnesium oxide in making refractory picks. And calcium oxide as a drying agent or basic flux. Now let's see what is pH. pH stands for the power of hydrogen ion concentration. pH, I repeat, pH stands for the power of hydrogen ion concentration. Now the pH of a solution is a negative logarithm to the base of 10 of the hydrogen ion concentration expressed in moles per liter. The number 7 on the scale represents neutrality of the solution, that is green color. If the pH is less than 7, then it is acidic. The substance, we consider the substance to be acidic. The nature of the solution is acidic. If it is more than 7, the nature of the solution is alkaline. You can see the color there. If it is less than 7, then it changes from green to yellow, yellow to orange, orange to red. If it is from 7 to 14, the alkalinity increases, then green changes to blue, blue to purple and purple to violet color. That means as the alkalinity increases, the color changes. Now, in a colorless liquid, there is a reasonably accurate pH value can be obtained by adding a universal indicator. Universal indicator is a universal indicator is a mixture of indicator dyes that gives a spectrum of colors depending on how acidic or alkaline a solution is. That means universal indicators give different colors to different concentrations of hydrogen ion in the solution. Now, for example, universal indicator produces green color in neutral solution, that is when the pH is 7. It changes to basic progressively from blue to indigo, indigo to violet as pH increases progressively from 7 to 14. Color changes in acidic solution from yellow to pink and then to red as pH progressively decreases from 7 to 1. Now, what is the importance of pH in everyday use? Let's see, our body works within a narrow pH value of 7 to 7.8. So plants and animals also survive in this narrow pH itself. Now, what is the use of pH in agriculture? That is how pH is important to a farmer. We know that every crop grows better in a particular pH. For example, rice grows better in acidic, slightly acidic soil, sugarcane in neutral and citrus fruits in alkaline soil. So, it is very important for the farmer to know the pH of the soil for particular growth of a crop. Now, pH is important in medicine, that is to a doctor, to diagnose certain diseases on the basis of the pH value of the blood and urine. Now, pH is used in the digestive system. In the digestive system also pH is important because hydrochloric acid is produced in the stomach, which helps in the digestion of food. But it becomes excess, that means the pH falls and the pain or irritation occurs. So to get rid of this, we take antacids. Doctors advise us to take antacids which contain magnesium hydroxide, which will adjust the pH value in our stomach. It is also used in preventing tooth decay. It is important to know because in preventing tooth decay it is important. Like when we take chocolates and sweets which are degraded by bacteria present in our mouth. So when the pH falls to 5.5, then the tooth decay starts. So tooth enamel, that is calcium phosphate, the hardest substance in our body that gets corroded, and this helps in increasing the pain. But the toothpaste is used to neutralize the excess acid present in the stomach. Now, if a bee stings, it leaves acid in our body. If baking soda is applied on the bee sting area, it gives us relief because it neutralizes the particular area. It is used by the cosmetic manufacturer because cosmetic manufacturers are those which prepare cosmetics like soap, then shampoo, body lotions, etc. Now, he has to know the pH value of the body because some have dry skin, some have moist skin, and accordingly these are used. So it is important for the cosmetic manufacturer also to prepare cosmetics according to the nature of the skin. We are going to concentrate on the next topic in the next video, that is salts.